The purpose of this video is to show the simple calculations that are needed to determine a surface area to volume ratio, which in biology is necessary to demonstrate why cells are not allowed to grow to big sizes. They have to remain small. So really quickly, lay out your page like this. Draw these two cubes and put on the numbers. We're not going to give them any units for now, just to show the measurements and calculations simply. Pause the video and make your paper look like this. Okay, so we're ready to get going. First thing you want to do is make a note that the basic equations for these calculations for surface area, simply you are taking the surface area for each side of the cube, 6 sides, and adding up those surface areas to determine total surface area for the cube. For volume, it's a lot easier. You just multiply length times width times height. And again, we're going to use simple shapes to make calculations extremely easier. So surface area of each side is where we're going to begin, right here for the top shape. So, here we go. To calculate the bigger sides, the 3 by 1 sides, I'm going to just multiply 3 times 1, obviously 3 times 4 sides, the top, bottom, and either side. That's going to give us 12. And then the surface area of the end parts, which are this dark green section here, and its counterpart on the other side. So 1 times 1 times 2 of those sides. So we're just going to add up our surface area for the 4 larger sections, surface area for the 2 smaller sections, so it comes out to be 14. And then we'll see the volume. Again, pretty simple measurement calculation, just taking length times width times height. So 3 times 1 times 1, obviously 3, gives us our ratio, 14 to 3. But in ratios, we always want to simplify everything to 1. So calculation's actually 4.66, but we'll just round up to 4.7. You could round to 5 as well, so the ratio is roughly 5 to 1 here. For the larger shape, you can see the length here is 4, width and depth are 2, so 4 times 2 for these bigger sides, and then times 4 sides, that's going to give us 32. And then the 2 edges, 2 times 2 times 2 sides is going to give us 8. So adding those up gives us 40. And again, volume is a lot simpler calculation. Just multiplying all the numbers, 4 times 2 times 2. This is going to give us 16. So again, our ratio here is 40 to 16, which actually calculates out or reduces down to 2.5 to 1. Alright, this next slide is actually going to mimic the surface area to volume ratio lab that we are doing with the, or did, depending on when you watch this, with the auger cubes, the pink cubes. These guys are blue, but it doesn't make a difference. So here we have 3 cubes. The perfect cubes is the key here. 3 by 3 by 3 centimeters. We're going to stick some units in now. 2 by 2 by 2 centimeters and a 1 by 1 by 1. So again, here comes the surface area calculations. And this time, instead of adding up different sides, since all sides are equal, we can just go 3 times 3, which is one of the surfaces, times 6, since they're all identical. So calculations there, 3 times 3 times 6. And we need to put our units in there, especially now that we're calculating surface area, we call these square centimeters, so 54 centimeters squared. And then again, volume. Maybe the easier one, just multiplying all these numbers, 3 times 3 times 3, and we get 27, which our ratio then is 54 to 27. However, reducing that, we get a 2 to 1 ratio. Moving on to the medium-sized cube, 2 by 2 by 2, that surface area is going to be 2 times 2 for one of the surfaces, and again there's 6 of the same, so we multiply that number times 6 and you get 24 square centimeters. And then of course volume, 2 by 2 by 2, You're going to get cubic centimeters this time, and that is going to be 8. The ratio now is, of course, 24 to 8. And reducing that, we get 3 to 1. Easy way to do the calculations is, guys, you're just dividing the bigger number by the smaller number. So 24 divided by 8, you get 3. And then your other numbers is always going to be 1. Your second number is always going to be 1. Same thing up here. 54 divided by 27 is 2. That just gives you your second number. Always is going to be 1 again. Then for that bottom one, here we go, surface area, 1 times 1. Again, one side is 1 times 1, 1 by 1. 6 sides, so we get a surface area of 6 square centimeters. And then volume, the simplest calculation on here, just going to be 1 cubic centimeter. Our ratio is going to be 6 to 1, and that's already reduced because our second number was 1 initially. And here's the key now to demonstrate why cells remain small. They require a high surface area to volume ratio, meaning a big first number is better than a little first number. You can see up here too, 1 is a bigger cube, it's a bigger cell. Right, so the bigger the ratio, the more efficient transport is taking place in and, I guess, through and around this smaller cube or smaller cell if we were to make the comparison.